Okay, so if you remember, we did this briefly last week, right? So you saw the difference in these graphs, right? The lines was that we just physically took each one of the graphs and we moved them up or down according to whatever the number was on the end, right? So you can see each of the colors there. There's the red one, there's the black one, and the blue one, and the green one, right? And that number on the end was taking all the points and physically moving the graph up and down. That's what the Q does, right? The Q is a vertical movement, right? So then it doesn't really change too much down here when we come here, right? The only thing that changes is I have a different looking graph, like what we would have graphed. If I had to graph the number of toothpicks, it would have followed this pattern, right? Something that looked like this. It's x squared, right? So if I plug these points in, I'm going to do this one in black again, right? The base graph. If I plug in -2 into x, -2 times -2 or -2 squared is 4, positive 4, right? And then 1, 0, 1, 4, right? So I end up getting the symmetry about the y-axis, right? So if I plot that now, it's 0, 0, 1, 1, -1, 1, 2, 4, and -2, 4, right? So then I get this, right? That's the base graph. You need to know that one, okay? This will be the, I think, third page. I think we're on, okay? And there's another one. If anybody makes a mistake, there's one more copy here, okay? Now, we know from the lines, I don't expect you to do this every single time, right? But we know from the lines now what this thing on the end does, the +2, right? It's going to take the original, the black graph, and I'm going to move every point in the black graph up 2 vertically. That's what it's doing, okay? And then you can confirm that. I'll fill out the table afterward, right? But remember we said I'm going to use the same values for x, right? Across all of these. So then I'm going to take each of these points and I'm going to move them up 2, 1, 2. And then this one's going to go 1, 2, 1, 2, 1, 2, 1, 2, right? So if I ask you, okay, what's the value of the red graph when x equals 2? What should it, or let's start at -2 because that's where the table's starting. What's the value of the graph? 6, right? How does that compare to this one? It's 2 bigger, right? So that confirms that I moved it up, right? What would happen if I plugged in -2 into there? I get -2 squared plus 2. What should that be? 4 plus 2, which equals 6, right? Okay? So then I know I could fill out the rest of the table, right? So I'm going to do the same thing, right? -1, 3, 0, 2, 1, 3, and 2, 6, right? Does that make sense? So this is the same thing as the lines. This thing on the end, the Q value, physically takes the black graph. You're always in reference to the base one with nothing on it, no Q value, and then you're moving it around. That's the whole point of what's going on, right? So with this, I'm going to take the values and I'm going to move them down 3, the black graph, okay? So I'm going to take this, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay? Right? Then you can do the next one if you wanted to or not. You can move it up or down. Okay? Now, does everybody see what I'm trying to get at now? Okay? So why don't you take a couple minutes, okay? I want you to look at, this isn't Q anymore. This is what's going to be called, we're going to have y equals ax squared. So you're going to put a number out front of x squared, right? So I want you to tell me what's happening to the graphs as I put a number out front of the x squared, right? So if I come down here and do the first one, still the same graph, right? 4, 1, 0, 1, 4. So I can plot that. So you should become pretty familiar with what this graph looks like, this y equals x squared. Okay? Now your job is to tell me, what is this? What is that 2 going to do to the graph? That's your question. Okay? You can use the table of values, plug in x's, get out y's, and plot them. Okay? And then we'll see what sort of relationship there is. Okay?